This is the 2-2B lesson, which is on dilations and proportionality. We're going to start on the third page. And we're going to look at some examples of similar figures. Last year, you might have discussed congruent figures. Those are shapes that are exactly the same shape and same size. But similar figures are the same shape but a different size, or probably a different size, because if they weren't, then we would just call them congruent. So similar. We're going to solve these similar figures, a couple of them. In order to do that, it says we're going to write a proportion, sort of like we've been doing in this module a bit. And on number 5, we're going to find matching sides, like those match up and go together. And these correspond or match up and go together. And these do, but they didn't give us anything here, so we could probably cross that off. Then we're going to build a proportion. And however I decide to move through this figure, I need to then be consistent in my proportion. So for example, if I decide to do big over small, I need to stick with that. Otherwise, I'm going to get a proportion that is not going to work. So big meaning like starting with X, that's the big side, which corresponds or matches with 6, which is the small side. And big is 25, which goes with 10 in the small figure. There are other proportions that work, but the key way to know that your proportion is the same as your neighbor's or mine is when you cross multiply, you should have 6 times 25 and 10 times X. If you don't have that, then you have an incorrect proportion. Before I cross multiply, I also noticed that this fraction on the right could be simplified like so. And so that means that the ratio of big to small is a 5-to-2 ratio, where the big one is 2.5 times bigger than the small one. All right, now that I've done that, I am ready to cross multiply. And I get 2x equals 30. And I got a little equation here, pretty easy to solve, and that's 15. My figure is not to scale, so just be aware this triangle to the left is not necessarily drawn at 2.5 times the size of the other one, but I can plug this in and just see if this is reasonable based on the sketch that I have. It looks reasonable. We're going to do the same thing on 6. We have similar figures that are 2 rectangles, a small one, and a bigger version of that small one, which is this big one. Before we get too far into this, I also prefer improper fractions. It does make cross products a little bit easier. And 18 times 3 is 54 plus 2 is 56. All right, so we're going to set up our proportion. It doesn't matter if we do big to small or small to big, but I just need to make sure I have matching sides and that I'm moving through the figure in a consistent manner. This time I'm going to do small to the big one and small to the big one. And I'm going to cross multiply. By the way, I have these complex fractions, which I'll need to resolve, but cross multiplying might actually resolve this. So I'm just going to leave them. And I can always backpedal if I don't like this, because 12x, that looks pretty good. And 1/3 times 56 thirds is 56 ninths. All right, next we're going to multiply both sides by the reciprocal. Might be the better choice here. And I get x equals, and 4 goes into 12 3 times, and 4 goes into 56 4, or 1 time with 1 left over, 14 times. All right, you can also use a calculator to help simplify this. I'm going to get a weird fraction though, which is 14/27. I prefer the fraction over this weird decimal. All right. Messier fractions, but the idea was the same. Build a proportion and cross multiply. Next, we're going to look at, and feel free to pause the video if you're still thinking about that. We're going to look at number 9, one more of these. This time we're going to draw a similar figure. It says on number 9, at the same time a 15-meter building casts a shadow, a man 1.8 meters tall casts a 2.5 meter shadow. How long is the building shadow? Draw two similar figures. All right, so here is the building. You don't have to draw it like this, but all right. And then here is a person. And it says that the 15-meter building casts a shadow and a man 1.8 meters tall. So we can think of this actually as our triangle, because the shadow is cast from the tip of this point down, and it produces a shadow line here and here based on the position of the sun. Okay. So this person is 1.8 meters tall. This person casts a shadow that is 2.4 meters long, and I want to figure out how long is, might be best to not use that color, is the building shadow, and this is 15. All right, so there is my similar figures. This is one moment in time, frozen, and these are going to be similar. All right, I'm going to do big to small equals big. We'll call this x to small. And I would like you to solve this. This comes out to be a whole number. It's nice, and it is a multiple of 10. You might want to pause the video to finish that. But when you're ready, we're going to look at one other thing, which is the IXL homework, which is you're going to be making similar figures using something called a dilation. If you've ever been to the eye doctor, which I have, and it's very uncomfortable, you get a drop in your eyes and your eye gets bigger. And we're going to make a similar figure by kind of dropping an eye drop and making this triangle either bigger or smaller based on the scale factor. And we're going to do dilation centered at the origin. So they're going to be based off the origin. So you can watch me do this one, and once you've understood one of them, you're welcome to go for it, but I will probably demo two. So point G is at an ordered pair of 1, 4. And if I'm dilating it with a scale factor 2 and making a triangle that's twice as big, this point is going to be twice the distance from the origin. So it's now going to be over 2, and it's going to be up 8. And you can see I'm about to draw the rest of it. Okay, then I've got point F, and I'm going to double its distance from the origin, which will also produce a triangle that's double the size. So if it is left 4, it's going to be left 8, and up 4 is going to be up 8. And the last point, F was left 3, so it's going to be left 6, and this was at -5, and it's at -10. Okay. So before we press submit, there is a way to check that we did this correct, which is, first of all, it should look twice as big, which it does. The center, the origin, through point F and the other point F, which we sometimes call F prime, these should all lie on a line. So if you have a ruler or kind of an edge of a note card, you could check. And then the origin to G prime should be on a line. And the origin to H prime should also be on a line. So if you can't see that, you probably have a mistake. Also, you'll notice that there are some parallel lines, like this line and this line are parallel, and this line and this line are parallel. So if you have matching or corresponding sides and they don't look parallel, then you have a mistake. All right, this one we're going to do a dilation of half. and we're going to do a square. All right, so we'll start with D. So it's going to be at 3, -3. And E is going to be at 3, 5. And F is going to be at 5, 5. And C was at -10, so it's at -5. And there we've got our figure that is half the size. And all the sides should also be half the length. And from the origin to D, and the origin to E, and the origin to F, and the origin to C should all be on their own lines. It might be 4 separate lines, which it looks like they are, and everything looks parallel. All right, and this one's a scale factor of 4. If you can't get it to fit on the graph, you know that you have a mistake somewhere along the way. So in this video, we went over similar figures. We did 3 problems in the lesson. Make sure that you do finish number 9. And then we talked about how to make similar figures by doing something called a dilation or a size change given a scale factor.